Hello guys, welcome to the session. So as we know, we are discussing problems on atomic structure. This is the second session of problem solving atomic structure. Okay. So we were solving some questions that has been asked in previous year exam. It helps you in both KPY or JEE or NEET exam. So those past year problems we are solving actually. Okay. So let us start with the session. Okay, let us discuss this question. Okay. The electrons identified by the quantum number n and L, these values are given and can be placed in the order of increasing energy from lowest to highest. Okay, easy one. You can easily compare the n plus L rule, compare with n plus L rule, which we also call it as Aufbau rule, right? N plus L rule. According to this rule, what we say? That the value of n plus L, the energy is directly proportional to n plus L value, right? If n plus L values are equal, then we compare n value. Okay, more value of n, more will be the energy. So let us discuss this. The first one, n plus L value for the first one is 5. For the second one, n plus L value is 4. Third one, n plus L value is 5 again. Fourth one, n plus L value is 4. Okay, so obviously second and fourth has lesser energy than first and third. Okay, so first and third, if you compare the n value, third has the minimum n value than lesser n value than 1. So the third one has maximum energy. Sorry, third one has minimum energy. Then we have first one, and then if you compare it is other way, right? The energy of 1 and third is more than to that of second and fourth. 1 and third, the energy of first is more. So first one has maximum. Then we have third. Second and fourth, n value if you compare, n value is lesser for the fourth one. So we have second here, and then in the last we have four. So this is the decreasing order of energy. So let's check the option. First has maximum, then third, then second, and then fourth. Option A is correct here. Okay, now question number 27. The number of nodal planes for xy. Pxy has only one nodal plane, that is YZ plane. Okay, has only one nodal plane, that is YZ plane. Hence, the answer for this one is option 1, that is only one, right? Perpendicular to the plane of x axis, that is YZ plane. Okay, answer is option. Okay, the next one you see. The wavelength associated with the wavelength associated with a golf ball weighing this much gram, moving at a speed of this 5 meter per hour, is of the order. Okay, so how do we do this? We know wavelength lambda associated with any moving object of mass m is h divided by mv. Okay, so h is the Planck constant. The value is 6.626 into 10 to the power minus 34 divided by m is 200 gram, the mass that we have. We don't have to change this. 200 gram, sorry, it is in gram. So we have to convert this into kg, the SI unit, because it is in joule per, it is in joule, right? 10 to the power minus 3 kg into velocity is 5 meter. We have to convert this r into second, so divided by 3600. Okay, just you need to solve this, you'll get the answer. So this is, you have to find out in order, so we can do this. Okay, suppose we have 6.6 into 3600 into 10 to the power minus 34 divided by 1000 into 10 to the power minus 3. Okay. So if you solve this, this will cancel out. And this would be so we have 1000 into 10 minus 3. So we have this one. So it's a calculation mistake. So 5 into 200 is 1000. 1000 into 10 to the power minus 3. That's right. 1000 into 10 to the power minus 3. Okay. So we need to solve this. So we get it here. This will cancel out and we get 66 into 360 into 10 to the power minus 30. Okay. So if you multiply this, what we get, just I'll do this just a second. So we have 66 into 360, 2376. So we are getting it as 23760 into 10 to the power minus 30. Okay, so fine. So we'll write down point here. 40 will come down 10 to the power minus 30. So answer would be 10 to the power minus 30, option C. In this order we get it as. Okay, now the next question is, quantum numbers plus half and minus half of the electron spin represent the rotation of electron in clockwise and anti-clockwise direction respectively, rotation of electron in anti-clockwise and clockwise direction respectively, magnetic moment of the electron pointing up and down respectively, two quantum mechanical spin state which have no classical analog. Okay, two quantum mechanical spin state which has no classical analog. Okay, so plus half and minus half, we usually say that it is the orientation of electron, right, about its own axis. If it is said to be clockwise orientation, it is plus half. If it is said to be minus half, it is anti-clockwise orientation. But actually it represents the magnetic moment, right? So it is a component of spin angular momentum, right? Spin angular momentum. And if it is plus half, right, then we say the component of this spin angular momentum is along in the direction of magnetic field, right? In the direction of magnetic field, and minus half, it is opposite to the direction of magnetic field, right? So plus half and minus half, it represents the magnetic moment of electron pointing up and down respectively, right? So usually for easier way, we say as when the electron enters into the orbital, it can have clockwise or anti-clockwise orientation, and that is plus half and minus half, right? But this actually represents plus half and minus half. This actually represents the spin magnetic moment, or simply we can say the magnetic moment when it is along the magnetic field and opposite to the magnetic field, right? So when it is along the direction of the magnetic field, right, then it is plus half, and when it is anti-clockwise, it is minus half. So answer for this question is option C, magnetic moment of electron pointing up and down respectively. Okay, now the next question you see, if nitrogen atom has electronic configuration 1s7, it would have energy lower than that of normal ground state, that is 1s2, 2s2, 2p3, because the electrons would be closer to the nucleus, yet 1s7 is not observed because it violates Heisenberg uncertainty principle, Hund's rule, Pauli exclusion principle, and Bohr's postulate of stationary orbits. Okay, so you see, Heisenberg has nothing to do with the electronic configuration. It deals with the uncertainty in the position of electrons. Correct? Hund's rule, it says the electrons occupies the orbital one by one, right? And then the pairing takes place, right? So pairing is not possible unless all the orbitals belongs to the same subshell is singly occupied. That's Hund's rule. Pauli exclusion principle is no two electron could have the same set of quantum numbers, right? But 1s, if it has more than 2 electrons, then obviously 2 electron is this. This is a hypothetical case. 2 electron is this. If you have suppose third one will have either clockwise or anti-clockwise orientation. This is the possibility we have. So it means the two electron in the same shell has the same set of quantum numbers, and hence it is not possible. That's why this particular question, it violates the Pauli exclusion principle, right? Okay. 33rd, the radius of which of the following orbit is same as that of first Bohr's orbit of hydrogen atom. Okay, radius of which of the following orbit is same? Easy one. Okay, so what is the first Bohr orbit of hydrogen atom? We know the formula of radius. The radius formula is in nth orbit, Rn is equals to 0.529 n square by z. Hydrogen is the first Bohr orbit means 529 into 1 square by 1 only, right? Same as the first Bohr orbit, fine. So if we talk about helium, so Rhe plus is 0.529 into 2 square by 2. Helium, the atomic number is 2. Obviously it is not equal. So we need to just compare the n square by z value for all this. Okay, if it is equal to 1, you see the value of this for hydrogen is 1. So for which of these ions it is 1? Okay, lithium n square is 2 square by 3, not equal. Li2 plus for 3 1. So it is 3 square by 3, not possible. Beryllium 3 plus, right? So it is 2 square by 4, the atomic number of beryllium, right? Hence, this value is 1. Answer is option D for this one. Easy one, just you need to compare the n square by z value. If it is coming out to be equal for hydrogen, that is 1, it is the same orbit as the first orbit of hydrogen has. Okay, fine. The next one. Okay, the number of radial nodes of 3s and 2p orbitals are respectively. Easy. See, radial node is equals to n minus L minus 1. So for 3s, it is 3 minus 0 minus 1 equals to 2. For 2p, it is 2 minus 1 minus 1, and that is 0. 2 and 0, the answer is option A. The kinetic energy of an electron in the second Bohr orbit of a hydrogen atom. Okay, so kinetic energy is what? Kinetic energy is half mv square, and the value of v is, in terms of h, we need to find out. Okay, so if you do not memorize this, you can easily derive this, right? How do we do this? We know the angular momentum mvr is the integral multiple of h by 2 pi. We need to find out mv square, half mv square, right? So what is v from this? It is nh by 2 pi into 1 by mr, right? This v will substitute here. So it becomes half m v square is n square by h square by 4 pi square m square r square. Okay, so this square and m will get cancelled, and we'll get here n square h square by 8 pi square m r square. Okay, kinetic energy of an electron, a naught is the Bohr radius. So E naught is equals to what? We know the Bohr radius is for 1 square by 1. This is A naught. So R square So how do we write down R in terms of A? A naught is this. So what we can write, R radius R is equals to, we can write down A naught into any orbit n squared by z's 1. So R we can substitute as A naught square n square here. Right. So we'll substitute R here. It becomes n square h square divided by 8 pi square m. R square is A naught square n to the power 4. So this square and this 4 will get cancelled. We'll get n to the power 2. Okay, so this when you solve, you'll get h square by 8 pi square m A naught square n square. H square 8 pi square m Is there any mistake? R is A naught n square. No, R square is n square. H 4 pi square. Okay, just cross check this. Okay, fine. So second Bohr orbit is given. That's what I was thinking. Second Bohr orbit is given. So we'll put here 4. So 4 square into this. Second word, so 2 square into 4. So we'll get h square by 2 square. 4 into 8 is 32. Pi square m A naught square. Right. Answer is option C. Okay. This is the answer. The energy of an electron in the first Bohr orbit of hydrogen atom is this. Okay. So it is given in the first Bohr orbit. So E1 is given. It is minus 13.6 electron volt. The possible energy values for the excited state of electrons in Bohr's orbit of the hydrogen. Fine. So energy we know it is E is equals to minus 13.6 Z squared by N square. Right, Z squared by N square. So this is the formula we have in electron volt. Now it is for hydrogen atom, right? So Z we don't have to think about because it is one only. N can be 1, 2, 3, anything, right? So if it is 2, if N is 2, we have to check this one by one. If n is 2, then energy for the second orbit is minus 13.6 divided by 4. So we are getting here 3.4 minus 3.4 electron volt. Okay, so this is possible. If n is equals to 3, then E3 is equals to minus 13.6 by 9, that is 1.946, 1.5 electron volt, minus 1.5 electron volt. You see, D is also correct. Okay, so minus 3.4, then minus 1.5. Then it means minus 0.4 in between these two, it is not possible, right? If you talk about n is equals to 4, then E4 is equals to, we are getting 0 point something, minus 0 point something, right? Because 13.6 by 16 would be 0 point something, which is not the case here. So option would be A and D, both possible into this one. Okay, it's a multiple correct question. So answer is A and D for this one. Which of the following statements is are correct? This is also multiple correct question. The electronic configuration of chromium is 4s1 3d5. This one is correct. The magnetic quantum number may have a negative value. Yes, that is also possible. Minus L2 plus L, it is there. The silver atom, 23 electrons have a spin of one type and 24th of opposite type. The atomic number of Ag is 47. Okay, so if silver atom, so silver is Ag, so it is 1s2 okay. "23 electrons have a spin of one type." Okay, means one type we have. So 1, 2, 3. So 23 will have opposite sign. Okay. If you see the electronic configuration of copper, so copper, zinc we have, and here we have Ag. If you look at the position of it, right? So copper electronic configuration is 4s1 3d10. Hence, silver would be, it is 5s1 and 4d10. 5s1 and 4d10. It means if 4d is filled, means 4p, 4s is also filled completely, right? And 3d, 3p, 3s also filled completely. So the configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s, 4p6, 4d, 5s1 and 4d10. Okay, so this is the electronic configuration. So it is 6 plus 4, 10 plus 10, 20 plus 10, 30, 40, 47. This one is also correct. Okay, 47 we are getting. Okay, all these you see 20 plus 10, 30, right? So out of 30, 5 electrons will have the same configuration, right? And here we have 10, 10 plus 5, 1, 2, 3 plus 2, 5 plus 1, 6, 6 plus 3, 9, 9 plus 1, 10, 10 plus 5, 15, 15 plus 3, 18, 18 plus 5, 23. 23 electron will have the same configuration and same spin. Hence, this is the answer. Oxidation state of nitrogen. Nitrogen is minus 1, and it is minus 1 by 3 and plus 1, right? -1/3 oxidation state of nitrogen we have. So I think option D is not correct. This is +1. +1 and nitrogen should be -1/3 so that overall it is linked. So answer is A, B and C for this question. Okay, next question you see. Decrease in atomic number is observed during what? Okay, so this one is, it's an information based question. You should know the relation here, what happens in alpha emission, what happens in beta emission, etc. Suppose you have an atom, I'm taking X, A, mass number and atomic number. If it goes under alpha emission, right? Minus alpha means alpha emission. Alpha means what? Helium particle. So helium particles comes out. So we have He, 4 and 2. Hence, the left here is A minus 4 and Z minus 2. Decrease in atomic number, right? You see the atomic number is decreased. It was Z initially, now it becomes Z minus 2. If this goes under beta emission, then beta emission is electrons comes out from this, right? So we'll get here X, A, electrons comes out, so E, 0 and -1, the charge we have here, means it is Z plus 1 to balance the equation. So here we have increase in atomic number, so I think D is wrong. So far this one is correct. Let's talk about the other one, that is positron emission, right? In positron emission means one positron, one positive charge comes out, so +1. So that would be simple one, X, A, Z minus 1. It means this is also correct, right? And the last one we have, if we have electron capture, means it takes one electron, plus E. It takes one electron. So it becomes X, A, and it takes one electron, so the charge decreases, right? Z minus 1. Right, so D is also correct. So A, C, D are the correct answer. The ground state electronic configuration of nitrogen atom can be represented by, means outermost electron is talking about. It is understood in this question. So N has 7 electron, 1 S2, 2 S2, 2P, 3. So 1s has 2 electron, 2s has 2 electron, and 2p has 3 electron, which is this according to Hunt's rule. Right? Hence, the answer for this question, it could be, this is not possible because either it is clockwise or anti-clockwise, correct? So, answer for this would be, this is also correct, and this is also correct. A and D both are correct in this one. Right. So these are the few questions we discussed. Okay, very basic questions. The next section we'll take some good questions, some higher level questions we'll see. But this kind of questions helps you in KVPY exam a lot. Okay, fine. Thank you guys. Thank you so much. Yeah.